Hey guys, don't forget to subscribe my channel and hit that bell icon for similar video notifications. Also, do comment on what else you would like me to add to this present video. Best regards, Electron. Hi guys, you are watching channel Mr. Electron. In my previous video you saw me make a DC motor high speed from an old mixer motor. You can see that I replaced the field windings. These were the field windings on this motor, and I replaced it with these concave ferrite magnets to make it a permanent magnet DC motor. So in this video I'm going to use the field winding of this motor to make a high current transformer. So guys, first I'm going to do the resistance check, pointing it towards 200 ohms. Checking resistance of both the coils. Coil 1 60.1 ohms, coil 2 70.2 ohms. Rechecking coil 1. Yeah, okay, 70.1. Both of the coils are 70 ohms exact. So guys, the second step is to connect these two poles in series to each other, and then finally connect both of them together to the AC home socket 220 volts supply. So guys, there is a brilliant way for doing pole checking. This what you see is a variable power supply. I bought it from Banggood's. Link for this product will be in the description. So DC supply, I will use it. You can see it is at present flashing 9.53 volts DC. Okay, and here as you can see 9 to 24 volts output variable at 3 amperes. So guys, the pole checking is very important to find which wire to connect which one, like if this blue wire will be connected to this small black one or this gray big one. So for that I'm going to do check on the first pole. I will convert it into an electromagnet and find out which pole it creates, like north and south. So connecting the DC supply 9.51 volts. You will see voltage fluctuating. Now the electromagnet has been created. Now I will use this small magnet to find out the pole, if this one is repelling or attracting. Yeah, this side is repelling and this side is attracting. So guys, I have finally figured out the poles. This wire, blue one, will be connected to this black one, and that is because you see this magnet and this clip, this part attracts this pole. So this face of the magnet should repel this pole, and accordingly the wires should be connected in series. So guys, I collected this copper wire from an old transformer, and now I'm going to wound this coil on this nut and bolt set. Okay, so let's do that. Hey guys, don't forget to subscribe my channel and hit that bell icon for similar video notifications. Also, do comment on what else you would like me to add to this present video. So guys, here as you can see I have given around 75 turns. Okay. So guys, as you can see, the secondary is ready and the wires have also been stripped. So it's time to connect it to this part. Now this is going to be one pole and this is going to be other pole obviously, and it will be connected something like this. Okay, in between these two field poles for best output. Little more, little more. Okay, the secondary has been connected in between both the poles, front view and back view. Okay, so let's connect the primary to 220 volts AC supply and measure the output voltage that we are getting on these two terminals. And guys, I forgot to tell you one thing. I have connected this black terminal with a jumper cable to this blue terminal, and the final input to the primary field windings will be given with this black and gray terminal. measuring the resistance of this coil, pointing towards 200 ohms, 3.1 ohm, again towards 200 volts AC for AC voltage measurement. Okay, so guys, as you can see, I have connected 220 volts AC supply with this pin to this transformer. Although it is turned off at present, I'm going to turn it on, and to the output of this secondary winding I have connected this multimeter with the meter pointing towards 200 volts AC mode. So keep watching the multimeter screen and I will go and turn it on. Okay, so guys, as you can see that it is giving an output voltage of around 13.8 volts AC. So guys, I have turned off the supply. Now I'm going to try and glow this car indicator bulb with the help of this homemade transformer. Now I'm going to turn on the supply. So guys, as you can see, it is working. Nice. So let's turn it off. I'll show you one more thing. Now guys, as you saw, although it is working, but it is not very powerful because the secondary winding is not a high current type. So for that reason, I'm going to try this 60 watts bulb and show you that this will not glow perfectly because it is going to consume large amps from this and it is not going to provide that. It is glowing with this also. Now that is interesting. Seems like the output is really efficient. Then this power supply is at least 60 watts. Wow, I didn't think that to happen. And as you can see here, it is written 12 volts 60 watts, which means that it is consuming somewhere around 5 amperes from this supply. Okay, so guys, since the output of this homemade transformer power supply is AC, so I'm going to convert it to DC with the help of this bridge rectifier 35 amperes KBPC 3510 Vanco. You see this terminal is AC, which makes this one AC, and the diagonal opposite is also AC. So these two are AC and these two are DC. So I'm going to connect these two AC terminals to this part, but first I'm going to turn off the supply. Okay, so guys, the supply has been turned off. And now we can get DC out of these two terminals. Okay, so guys, this is a 24 volts Japanese DC motor, DC servo motor. So I'm going to test run this motor with this power supply first. Yeah, actually the power supply is turned off right now, so I will have to switch it on. Before that I will keep it steady. Yeah, this seems fine. Okay, let's turn on the supply. So guys, as you can see that it is working pretty good. So this is a 2 amperes 24 volts motor that I am running. Let's replace this one with another one. So guys, now I'm going to test another motor which is a little bigger than the previous one. This is a 100 volts and a 6 amperes DC motor. Okay, so I'm going to connect its wires to the terminals. Yeah, so this has been connected. Let's turn on the supply again. So guys, as you can see, it is working. So guys, now I'm going to tell you how to charge this 12 volt 7Ah UPS battery with this supply. Obviously the output is 13 to 14 volts DC, so it can easily charge a UPS battery which charges on 12 volts DC. This one is positive and this is also positive, so positive to positive. Pointing towards 20 volts DC, positive to positive. Let's turn on the supply, and if voltage increases, then this means that the battery is charging. So let's test it. So guys, as you can see that the voltage has started increasing, and this homemade transformer is feeding electricity to this battery, and this battery is gaining voltage. Okay, so guys, that would be all about today's video. Thank you so much for watching it. Please hit like and don't forget to share and subscribe.